Here we have the absolute value of x is greater than or equal to 4. And hopefully, if you're watching this, you are already familiar with what an absolute value is. Basically, what it is you take the term inside the absolute value, and whether it's positive or negative, the output is positive. So in this case, the absolute value of x is greater than or equal to 4, which means any number x, as long as it's greater than or equal to 4, will be a solution. And so let's look at it from that standpoint. We have obviously over here we have 4, okay? And then of course, if we go to the negative side, let's say we had the absolute value of where x is negative 4. So we have absolute value of negative 4. And again, as I just said, the output of any absolute value turns any number into a positive, so it will be 4. So our other side will be negative 4. And again, as you recall, since it's greater than or equal to, this equal sign means that this value, negative 4, will be included. And this value, positive 4, will be included. Okay, and now the question is what part do we shade? Well, obviously, if x is greater than 4, that will be 5, 6, and on. So we know we're going to be shading up here. Okay, so we'll have that part. And let's go to the middle piece, the middle region, and let's try 0. Okay, obviously if x is 0, it is not greater than 4, so the middle piece is not going to be shaded. Okay, now let's go below negative 4. Let's try negative 5, and once again the absolute value of negative 5 means we turn it into a positive, and of course 5 is greater than 4. Therefore anything less than negative 4, negative 5, negative 6, negative 7, and on will also be a solution to the absolute value is greater than or equal to 4. So there you have the first example. So looking at that, let's move on to a second example. Here we have graph the absolute value of x plus 3 is less than 7. And so a strategy I like to do is look at a problem, ignore the less than or greater than sign, and solve it as if it's equal to find our critical values. Okay, so assuming that, let's say we had the absolute value of x plus 3 is equal to 7. Okay, and as we stated before, absolute value takes any value and makes it a positive. So if we could get negative 7 in here as well, it would turn it into a positive 7. So this is going to basically lead to two problems. We're going to have x plus 3 is equal to 7, and we're going to have x plus 3, this right here, x plus 3, can also equal negative 7. So we basically have turned this into two problems. And in the first case, it's obvious, it's x is equal to 4. Alrighty, so we're going to put x equals 4 as one of our solutions. And then the negative alternative would be, of course, we subtract 3 from both sides, and we get x is equal to negative 10. So x is equal to negative 10. Alrighty, so those are our two values that would be equal to 7. So let's put them on our number line. We have negative 10 here, and we have 4 here. Alrighty, and again, these are what I call critical values because they basically separate whether your regions into whether they're going to be shaded or not. And so what we're going to do now is first establish that this is less than 7, which means it's not going to include 7. So we need to make these open circles. We are not going to include 4 or negative 10. And then finally, we're going to test. We have three regions, less than negative 10, between negative 10 and 4, and then greater than 4. So let's try the middle one first, 0. Okay, if we plug 0 into the original equation, 0 plus 3 is 3, less than 7. That is correct. So we can actually shade the middle. Okay, there's different ways of shading. Some people draw a line. Some people could squiggly marks like that. So the middle, and let's take a look at above 4. Let's plug in 5. If x were 5, we'd have 5 plus 3 is 8, and 8 is not less than 7, so we're not going to include the upper bound. And then let's go below negative 10. Let's try negative 15. And negative 15 plus 3 is negative 12. And again, it's an absolute value, so negative 12 becomes positive 12, and 12 is not less than 7. Therefore, this region will not be shaded as well, and our final solution is simply the area in the middle. And then our third example, Let's graph a number. Notice there's a slight difference with this one. We have an absolute value of x plus 3 instead of the absolute value of x plus 3. We have the 3 on the outside. And I always recommend when you are working with absolute values, try to isolate the absolute value. So in this case, we're going to subtract 3 from both sides. Okay, and now we have a problem that's the absolute value of x is less than 4. Okay, and once again, I like to set it equal to 4, which of course would be 4 or negative 4. All right, and so let's put 4 and negative 4. And once again, it's less than, so we're going to have an open circle. Open circle for both. And again, we're going to test all the regions. All right, and we again have try 0. 0 plus 3 is 7. That's true. And then, of course, we have try 5, it does not work. Try negative 5, it also does not work. And we basically have the same graph. And I'm going to actually shade it with a line. Okay, let's take a look at this one. We want to graph 2 times the absolute value of x plus 3 less than 8. And again, I like to stick to the plan of first establishing what are our critical values. Okay, so let's solve for this. We're going to have 2 times the absolute value of x plus 3. I'm going to set it equal to 8. We'll come back to the less than later. And again, when you solve absolute values, a good idea is to isolate the term inside first. So we're going to divide both sides by 2. And we're going to end up with x plus 3, absolute value, is equal to 4. Okay, and then how do we solve this? Again, I split it off into 2 sides. X plus 3 equals 4 is the positive component. And then x plus 3 equals negative 4 is the negative component. So our 2 solutions will be x equals 1 over here and x equals negative 7 over there. And of course, you can plug it in to check your work. So we have our 2 critical values, so let's put them in here. We have 1, there's 0, there's 1, and negative 7. Okay, and then again, we go back to the original problem. Now let's start putting in the less than part. It's less than, there's no equal, so we're going to have an open circle and an open circle. And now we get to establish which parts do we shade. Let's try 0. 2 times, this will be 3, 6 is less than 8. So we know the middle is going to be shaded. And then I like to check actually the outer parts to see if they indeed will fail. If we try 5, we have 5 times plus 3 is 8 times 2 is 16. This does not work. And then of course negative 10 would be, negative 10 plus 3 is negative 7, but the absolute value makes it positive 7. Times 2 is 14, less than 8, so that does not work either. Okay. The second problem is the following. We have the absolute value of x minus 4 minus 7 is greater than negative 3. And once again, even though all absolute values are greater than negatives, we have this little negative 7 piece, so we need to move that over first. So let's go ahead and do this one. I'm going to rewrite this. Here's the x minus 4 absolute value, and minus 7 is equal to negative 3. And let's solve. So we're going to, again, isolate the absolute value. Absolute value of x minus 4 is equal to 4. And again, we branch this off and separate it. So we'll have x minus 4 is equal to 4. And then the counterpart will be x minus 4 is equal to negative 4. And so our 2 solutions will be x equals 8 and x equals 0. Alrighty. And again, we can check it quickly if we had to by plugging it back in. We'll get to that later. Let's start with, again, it's going to be a greater than. So open circle for the 0. And then x equals 8. And open circle. And now we get to test points. Again, 0, 0 minus 4, negative 4, positive 4, minus 7 is negative 3, correct. 8 is 4, minus 7 is negative 3. And let's start testing the 3 regions. We have negatives. Let's do negative 2. Negative 2 minus 4 is negative 6. This becomes positive 6. minus 7 is negative 1, which is greater than negative 3. So negative 2 works. So this side over here will be shaded. Okay. And let's try the middle part. Let's pick 4. 4 minus 4 is 0. That's convenient. 0 minus 7 is minus 7. And minus 7 is not greater than negative 3. So the middle part will not be shaded. And then finally, let's take 10. That's on the larger side of 8. 10 minus 4 is 6. 6 minus 7 is negative 1. And negative 1 is greater than negative 3. So this one, the arrows go outward. So all values less than 0 and all values greater than 8. And our third example in this batch, negative 3x plus 1, absolute value less than negative 7. Alrighty, and again, apparently it would look like you can't have this absolute value less than negative 7, but we have this negative sign over here. And really what this is it's like negative 1 times this whole thing. So let's divide the whole thing by negative 1. And so we're going to get 3x plus 1, absolute value, 7. And the question is, are we going to have to flip signs or not? We're going to find out later. So I'm going to leave this as equal for now. We'll find out later when we test our points. Okay. And again, we have our absolute value isolated. So let's find our critical value, which is on the positive side will be 3x plus 1 equals 7. So that's 3x equals 6. That's x equals 2. And then let's take the negative component. 3x plus 1 is equal to negative 7. And again, we have 3x is equal to negative 8. X is equal to negative 8 thirds. So we have a flip-flop here. We have x2 over here, and this is negative 8 thirds over there, which is negative 2 2/3. Alrighty, and those are our critical values. And again, it's less than, so we're going to put an open circle. And again, as we just mentioned a minute ago, I'm not sure which way it is, left or right. You may flip the sign, you may not. But it really doesn't matter, because once we have our critical values, we can just test the points, and that'll determine which way this symbol goes. So let's try 0. If we plug 0 into the original, we get 0 plus 1. Negative 1 is negative. So the 0 does not work. So we can actually go to this one, and as it turns out, we did have to flip the sign. 0 does not work in here, and 0 did not work in this one. Okay, in the middle. So let's try 5. Plug it in. 3 times 5 is 15, 16. Negative 16 is less than negative 7. So we shade this outer part. And then this middle is no good. And chances are this is going to be correct as well. Let's see. Let's take negative 5. Negative 15, negative 14, absolute value, makes it a positive 14. Then it gets flipped back to negative, and negative 14 is less than negative 7. So again, we end up shading both of the outers, and the middle stays open. So again, it's a 3-part process basically. Solve for the absolute value, finding your critical points. Most likely there'll be 2 of them. And then determine if it's an open circle or a closed circle, and finally test the regions with the original equation to see what you shade.